You were told this blood was different, not rare, different, that if you carry it, you might not be entirely human. Search it online and you'll find the theories waiting for you. That Rh negative blood came from ancient astronauts, from a lost race the old texts called the Nephilim. From the Anunnaki, visitors who, the story goes, left their mark inside your veins. It's a seductive idea. It explains why this blood is rare, why it seems to run in certain families, certain regions, why it can turn a routine pregnancy into a medical emergency. There's just one problem. When you actually read the DNA, when you look at the gene itself, the truth turns out to be stranger than the myth, and it's been hiding in plain sight the whole time. This is the real origin of Rh negative blood, and what the DNA actually says. For as long as people have known this blood exists, they've told stories about it, and the stories are big, cosmic. They promise that Rh negative people are the descendants of something ancient and hidden, that they carry secret abilities that their blood refuses to fit the ordinary human family tree. Those stories have millions of believers, and I understand why. Because underneath the fantasy, there really is something here that science struggled to explain for a very long time. The myth grew in a real gap. So let's do what the myth never does. Let's actually look. First, let's be clear about what Rh negative even means. On the surface of your red blood cells sit tiny proteins, antigens. One of them is called the Rhd antigen. If you have it, you're Rh positive. If you don't, you're Rh negative. That's the whole difference. A single protein, present or absent. Most people have it. Around the world, Rh negative is the minority, and how small a minority depends entirely on where your ancestors came from. In East Asia, it's vanishingly rare. In Vietnam, fewer than 1 person in 1,000. Across much of Africa, a few percent. But in Europe, it climbs to roughly 15%, about 1 in 7. And this is where the first riddle appears. Because this blood, by all the rules of biology, should not be here at all. Here's why. Before modern medicine, an Rh negative mother carrying an Rh positive child faced a real and terrible danger. Her immune system could turn against her own baby's blood, reading it as an invader and attacking it. The condition is called hemolytic disease of the newborn. For generations before we understood any of it, it caused stillbirths. It caused loss. Quietly, in family after family, across centuries. Now think about what that means over the long span of human history. A gene that endangers your children is exactly the kind of gene natural selection should erase. Slowly, generation by generation, it should have been weeded out. It should have faded towards zero. It didn't. Not only did it survive, in some places, it flourished. And nowhere on Earth more than in one small corner of Europe, tucked against the Pyrenees mountains between France and Spain. The Basque. Among the Basque, Rh negative doesn't sit at 15%. It reaches 35, even 40% of people. The gene behind it, by some estimates, approaches half of everyone in the population. It is the single highest concentration found anywhere in the world. So now we have a genuine puzzle, not an invented one, a real one. A gene that should have been punished out of existence instead became one of the most common variants in Europe, and it reached its absolute peak in one ancient, isolated people. Why? What kept it alive? To answer that, we can't lean on legends. We have to open the one archive that doesn't lie. We have to read the gene itself. When scientists finally sequenced the DNA behind Rh negative blood, they found something the myth never predicted. Something almost the opposite of what all the theories promised. The alien stories all say the same thing in the end. that Rh-negative blood contains something extra, something foreign, a code that doesn't belong to this earth. The DNA says the reverse. Rh-negative blood isn't defined by something added. It's defined by something missing. In most Rh-negative Europeans, an entire gene, the gene called RHD, the one that builds that RHD protein, is simply gone. Deleted, cut cleanly out of the genome. Where a positive person has a working set of instructions, a negative person has an empty space where the instructions used to be. And we even know, roughly, how it happened. The RHD gene sits on chromosome 1, flanked on either side by two nearly identical stretches of DNA. Geneticists call them the rhesus boxes. Every so often, when a genome is being copied, those two matching stretches can line up wrong and splice together, and the gene sitting between them drops out entirely. One molecular slip, one deletion. So the great mystery of Rh-negative blood, the thing the myths dressed up as alien engineering, is at its core a gap, a missing page. This blood is rare not because something was written into it, but because something was erased from it. And that erasure appears to have happened essentially just once. When researchers compare Rh-negative people across Europe, the deletion traces back to what looks like a single ancestral event. One mutation in one person, deep in the past, then copied forward across countless generations. Almost every Rh-negative European alive today may be carrying the quiet echo of that one moment. While we're clearing away myths, let's take one more with us. You may have heard that the Rh itself is a clue, that Rh-positive people are the ones descended from monkeys, and Rh-negative people are somehow not. The name comes from the rhesus macaque, a monkey used in a 1940 experiment that first revealed this factor. That is all it is. A laboratory name from 1940. It says nothing about anyone's ancestry. Every human being alive shares the same deep primate lineage. Rh-negative people did not skip evolution. They inherited a deletion. But that only sharpens our riddle, doesn't it? If this gene is a dangerous accident that began with a single person, how did it ever spread to 1 in 7 Europeans? How did it come to define the Basque? For a long time, the assumption was that the answer had to be selection, that the gene must secretly do something, some hidden advantage that outweighed the danger to newborns. Protection against a disease, maybe. A parasite, something worth the cost. So researchers went hunting for that advantage in the genome. In 2012, one team used large population datasets to test exactly this. Was there any fingerprint of natural selection quietly favoring the Rh-negative deletion? They found none. No signal of a hidden benefit. No sign the gene was being pushed upward by some advantage. And that absence pointed to a quieter, stranger answer. Chance. Not selection. Drift. Picture a small founding population, cut off by mountains and history, marrying largely among themselves for thousands of years. In a group that small, a gene doesn't have to be useful to become common. It only has to be present at the start. By sheer luck, a variant carried by a handful of founders can ripple outward until it stamps itself onto an entire people. Geneticists call it the founder effect. And the models suggest that once the Rh-negative gene had already climbed high, near half a population, selection barely pressed on it at all anymore. It simply stayed. The Basque, with their ancient language, unrelated to any other tongue in Europe, and their long isolation against the Pyrenees, they weren't marked by design. They were shaped by time and distance and luck. The mountains didn't only guard a language, they preserved a gene. And here, just when the story seems finally solved, is where it cracks open again. If this deletion is so old, so deeply rooted in Europe, the natural next question is, how far back does it reach? Before farming? Before the Ice Age? Could it go all the way back to the other humans who once walked this same continent, the Neanderthals? It's a thrilling idea, and in 2025, scientists were finally able to test it directly. They recovered DNA from ancient bones, both Homo sapiens and Neanderthal, some over 100,000 years old, and reconstructed their blood types straight from the genome. The Neanderthals did carry Rh genes. In fact, they carried a strange version all their own, one so distinct it helped researchers redraw the family tree of this gene entirely. But the deletion, the specific missing gene that makes modern Europeans Rh negative, was not there. It wasn't in the Neanderthals. As far as the ancient DNA can currently show, that particular erasure belongs to us. To modern humans, arising sometime after we parted ways with those older cousins. Sit with that for a second. We went looking for an ancient origin to finally close the case, and instead, the case opened wider. The one clean answer we were hoping for dissolved in our hands. The mystery didn't shrink, it grew. If this is already breaking what you thought you knew, good. Hold that thought for the comments. Because here's the honest state of the science. We still can't fully tell you why this gene survived, or exactly when it first appeared. There are new clues, hints that Rh-negative people's immune systems may respond differently to certain infections. One study during the pandemic suggested Rh-negative individuals may have fared slightly better against the virus. Another found Rh-negative men mounting a stronger response to influenza. But these are early findings, whispers, not verdicts. The researchers themselves are cautious, and so should we be. The truth is that the final chapter on this blood simply hasn't been written yet. So let's come back to where we began. To the myths, the astronauts, the Nephilim, the Anunnaki. It would be easy to just laugh at them. But I want to do something different. I want to ask why they exist at all. Because here's what I think really happened. People looked at this blood and they felt correctly that there was a genuine mystery in front of them. They sensed something unexplained, and they were right to. That instinct wasn't foolish. What they were missing wasn't intelligence. It was the tool to read the answer. So they reached for the biggest story they could imagine, and they reached for the stars. But the real story doesn't need the stars. Because the real story is this. A single change in a single ancestor tens of thousands of years ago. A quiet deletion carried out of Africa and across a cooling continent. Preserved by isolation, amplified by pure chance, concentrated in a mountain people who kept an ancient language alive right alongside an ancient gene. A variant that should not have survived and did. That endangered children and endured anyway. And that, even now, we do not fully understand. That is not a smaller story than the aliens. It is a far larger one. It's the story of how an entire population can be shaped by a single accident, of how the human genome carries the fingerprints of migrations that no written record remembers, of a mystery so real that our best science, right now, still hasn't reached the bottom of it. The myth said your blood came from somewhere else. The DNA says something better. Your blood is a record of survival, a page from a history older than any book, written into the body itself, and still being read. And here's the honest truth. After everything the DNA just showed us, science still doesn't fully know why this blood survived. That unanswered question, that's exactly why I keep making these videos. So this is where I turn it over to you. If you carry this blood, or someone in your family does, tell me where your people come from. Your region, your surname, that strange story your grandmother used to tell. Every one of them is another point on a map we are still drawing together. This channel was never me handing you answers. It's us, chasing the same questions. The comments you leave send me back into the research, one layer deeper, for the next piece of the story. So thank you truly for watching. Drop your thoughts, your questions, whatever you're carrying with you. Keep it kind, keep it curious, and I'll see you in the next one.